we go. I was singing and dancing background. I don't know if y'all were or not, but super excited to be here. This is my first ever hosting, because I've been on the show before, hosting of Containers from the Couch, and I'm super excited. Also, super excited to have these gentlemen with me. So I'm gonna take a real quick moment, and as y'all can tell a little more about yourselves when you come to your talk part. But when you come to your talk part, you wouldn't know I've ever hosted before. So, Ollie, Simone, super glad to have you here. Today we're going to be talking about containers, serverless containers, which is also, or could be serverless containers, which is also fun. Ollie, I'll let you clean that mess up later. But this is Containers on the Couch. We talk all things containers, ECS, all things, and we have a lot of fun with that. So what we're here to talk to you about today is with Service Connect, which, me going is Service Connect kind of tells you I'm not the expert on this. I'm actually Ollie. I would love it if you'd kind of give us an intro and talk about what Service Connect is and tell us who you are and what you do.
Yeah, absolutely. So hey everybody, my name is Ollie Pomeroy, and I'm a specialist solution architect here at AWS. So I help our customers kind of build solutions, deploy workloads using our container services. Been working on the Amazon ECS team and the Fargate team in the past, so super familiar with these services and excited to talk about Service Connect. I guess, I'll start a little bit on like what is Service Connect, because I think there's a lot of people trying to understand exactly where it sits. Is it a feature? Is it a service? Why would I use it? Etc. And so I'm going to start right at the beginning a little bit and then kind of build it up as I go. Eric, ask questions, interrupt me, because I will.
Oh, I will. Yeah. I'm going to let you get in a little bit and let you get your groove going before I break it and interrupt you. But yeah, I have. So I'm not. So just so you know, I'm a principal developer advocate for serverless. However, last year I started taking on some container stuff. I have been driving Ollie nuts. He knows I'll ask questions. He's had more calls with me than he ever wants to know. But I love ECS and I love what it can do. But yeah, this is all brand new to me. So I'm going to ask the questions.
All right. Just to help them, just to kind of build it up a little bit, I'm going to start with a really, really basic diagram and talk about some of the options we have on connecting together different microservices. So here we go. We have two different services. Both of these are going to be deployed on Amazon ECS. And in Amazon ECS, the deployable unit is a task. So like that is what we're deploying. So here we have two microservices, one on the left with 4 tasks, one on the right with 4 tasks. And the question is, how do we want to talk between the two services? Now, option number one, maybe you could say is the traditional way to do it, is you put a load balancer between the two sets of services. And so you create a load balancer in AWS, that's like an application load balancer. You can register those tasks to the load balancer, and every time a client request goes in, it just routes around between the tasks. Now, works pretty well. It's a load balancer. It's going to round robin between the tasks. It's going to have some nice health checking between the tasks, so it knows when the task is healthy or not. But you can imagine if you started to have lots of microservices, tens or hundreds of microservices, you're then going to have like tens or hundreds of load balancers, and it becomes a bit of an operation just kind of managing these load balancers all over the place. So as people got involved in containers, people got involved in container orchestrators, we went to the second option when we then started moving towards what I say is service discovery. And this is when we kind of moved the load balancers out of the way, right? We don't have a load balancer distributing traffic. We went back to traditional mechanisms of just DNS. And there's lots of different ways to implement service discovery depending on your container solution. But in Amazon ECS, what we can do is we can register tasks inside of Route 53. We do that through a Cloud Map service. And now for one microservice to talk to a second microservice, we try and we look up a friendly name, we retrieve an IP of a task, and we make a direct connection to the task.
Okay, I'm gonna interrupt you here. Okay,
go for it.
So looking at this, okay, so you're doing a DNS, which DNS is not a new thing. Of course, you know, again, coming from serverless, it's like I don't even know what site or an IP addresses are, but they all exist. We still use them. They're just abstract away. But here, they're not. Here is something we use now. Doing a DNS lookup here, is this a private DNS or a public DNS? So Correct. Is this something everybody has access to get to a task, or just the tasks?
Correct. So for service discovery, primarily when you're like inside of a container platform, it's a private DNS. Like it's normally like a friendly name of I don't know, like service 2 or backend or whatever it may be.
Okay.
And it's not something that's like exposed to the internet. No, it's normally a private DNS. And in AWS and with ECS, this is like a Route 53 private hosted zone that you're using to have these friendly names and then the task IPs.
Okay, so I made like one task is reporting, and another task is I don't know sales or something like that. And so I can just say reporting, and it knows where to find that. And the cool thing behind that is if I have an unhealthy one or something like that, it's replaced. It's going to get moved around, and that's fine. Now I show the task in service 1 talking to all the tasks in service 2 that way. How, and this may be one of those questions like, come on, Eric, but how does task in service 1 talk to another task in service 1? Does it use the same thing, or is there another way for them to communicate within the tasks or within the microservice?
So it's probably rare to say that you would like communicate within a service. You know, like a task, these are identical replicas. So in theory, you could everything in microservice 1 could be like all of the web servers, like the front end, the user interfaces, and then everything in microservice 2 is your APIs. Okay. And so you're not really going to be talking like web server to web server. You'd be talking like web server to API server.
So I was seeing the microservice as like a micro application, maybe multiple tasks. And that obviously makes a lot more sense what you're saying. So, okay, gotcha. All right.
Yeah. So like this is kind of the way we've been doing container to container communication for a long time. There's a few kind of drawbacks to this approach, even though it's great, it's resilient, it's fairly easy to understand. The first one is just from a load balancing perspective. Like the task in microservice 1 knows which one to communicate to just purely on whatever is like the DNS response, and so it's kind of you're just getting basically the first IP or maybe the same IP every time to communicate to. There's not much distribution across load, right? It's up to the application to decide what's it want to do in terms of where it wants to route the request. It does a lookup, it gets 4 IPs. It's probably just going to pick the first one and send the request. It's not going to do anything more intelligent than that.
Okay.
The second thing is you as a platform team, you get very little information about where it the request, like where it was sent. Was it a successful response? What was the latency of that request? Right? There's no intelligence really from the client. It's just
a router.
Just sending a request to an IP and nobody's any smarter. So there's very little observability in this service discovery world.
Okay.
And then finally, like if you have to kind of handle or improve resilience inside of your application, maybe you need to do retries between the microservices. Maybe you need to take out a microservice that's overwhelmed. All of that logic has to go on the client. So all of this logic has to go in this diagram in microservice 1, right? You're going to have to put all of your have to put all of your retry logic in there. You're going to have to put all of your kind of maybe some of your dependency checking, health checking in there. So we then evolved from this as a container community, and you then moved into the world of service meshes. And service meshes is this idea that we're now basically putting a proxy, and this is like a reverse proxy, traditionally using the Envoy open source technology, but there are service meshes out there that use other proxies. And you now have something more intelligent to do the routing of the requests, to generate some observability information, to put some health checking and resiliency and stuff like that in there. So that's kind of like the evolution. And then today we're talking about an Amazon ECS feature called Service Connect. And Service Connect is a managed service mesh for Amazon ECS.
And is it based on Envoy as well?
It is based on Envoy as well. So like all of like in lots of other service meshes, it's kind of up to the platform team to put these proxies in the tasks. And that can be quite an operational burden, especially like if you have different application teams between all the different microservices, and like how are you going to distribute the configuration of the proxies? Like it can be quite a manual task, and so that's something that we're trying to solve with Service Connect, which we're talking about today.
All right, so that kind of handles this placement and management of the. And I'm going to say it. I'm going to throw it out there. I don't want to steal your thunder, Simone, which we're going to get to Simone in a minute. But the sidecar, right?
Yeah, absolutely.
What's up? I'm sorry. That's a silly thing to be proud of. But forever people would say sidecar. Oh, it's a sidecar. And I'm like, that's how you put another monitor on your Mac, right? Through iPad. Yeah, that's the old way, So this is great.
Yeah, there's lots of little container terminologies these days, and yeah, the sidecar is the idea of having like supporting containers to your application container, and the supporting container could be a log router, it could be a monitoring service. In this context, the supporting container is the proxies.
Okay. All right.
Makes
Are we
sense?
ready to demo, or do you still have more? You have more to show?
No, I'm good unless you have questions.
No, well, I do. I have plenty of questions, but I'm gonna move us on a little bit here to our next guest. Super excited to have you, Simone. And all right. First of all, let's get this straight. Am I saying your name correctly, Simone?
Almost. Simone.
Oh, it's
Simone.
easy.
That's my
nice.
Yeah. I know. It's difficult.
Right. So you say it. Tell me how to say it correctly.
Simone Tallevi.
Okay, Simone.
That's gonna be tough.
Is that T silent?
No. T is loud.
Simone Tallevi.
Tallevi.
Okay, we won't waste time. We'll take this offline. But
story of my life.
What's that?
The story of my life with the surname is a little bit weird.
yeah, well, that's all right. That's all right. So tell us who you are. I'm going to go ahead and take. We're going to take Ollie's screen off there. Tell us who you are, what you do, and then we're going to get. We're going to like get our hands dirty here and show how this works, which is super exciting because your slides were great, Ollie. I'm not knocking your slides. I'm just saying we want to see some code. We want to see if you're watching me, we make mistakes. Simone will probably not. He'll do great. So tell us who you are.
Okay, I'm Simone Tallevi. I'm a partner solution architect in AWS. I'm taking care of our partner, try to help them build solution and architecture, reviewing architecture and so on. And also I'm part of our internal TFC community. I'm taking care of container, and over the past years, I've been working a lot with the ECS, Service Connect, supporting our customer. So I'm really excited to be here. Thank you for the opportunity to show you this demo. And today I'm going to be the demo guy.
Demo guy, that's right. and live demo, no recordings here. So this is awesome. So are you ready for me to bring the screen up?
Yep. Go ahead.
All righty. We'll do it here. Let's pop that in. Okay.
Okay. So before jumping to the demo, I just want to set the scene a little bit as well, give you a little bit of context. Let's imagine for a moment that you are a developer, maybe many of you connected are a developer, that are building a new application, retail store application. Imagine you've been tasked to build this and you're working on your microservice architecture, and you start working on your local machine, everything was great because you're creating your container, your UI, and then connect to your backend, and you spin up multiple containers on your local machine and everything's great. But then suddenly you realize that you need to go to a realistic environment, production environment, and maybe deploy these things to ECS and on Fargate on the cloud, and you realize that you need to handle a lot of complexity in the communication between those microservices. And then is where you realize that maybe you need something to simplify the naming, the service discovery for your service. Maybe you need to worry about retry mechanism in your service, or having a reliable communication, and also metrics really important, and security. Imagine that you are in a specific domain, or you need to have to maintain a specific requirement regulation, you want to have your connection between microservice secure, maybe with TLS encryption enabled. All of this complexity, it can be handled with you for ECS Service Connect. And that's what I want to show you today in this demo. Okay.
All right.
And before jumping again to the demo, let's have a look at the architecture. So we're talking about retail store application. So here we have three microservices, one UI service that essentially will show the front end of our application, and two backend, one catalog that is taking care of the catalog of our product, fake product, and backup by Aurora, Amazon Aurora, and cart service that is essentially supporting our basket or purchase for our catalog product. I want to show you, for this architecture, the first architecture, I kind of pick it up the first version of Oli, like with the all-load balancer, no? The traditional version that you will build in the architecture on ECS, and to show you what's the component and what's the difference between building with load balancer and with Service Connect. So with load balancer, you will have probably a load balancer, okay, an entry point on your load balancer facing your user, but then internally for the microservice to microservice communication, you will have an internal load balancer. And probably you will have maybe some CNAME associated to load balancer to have a friendly name. And so you will have also to handle the Route 53 and DNS configuration for your internal DNS, the internal load balancer. All of this, again, as Holly said, it can be a lot of work, a lot of operational overhead for the application, and as well, usually is in big enterprise companies, it's usually handled by different teams. It's more like you're moving out of the developer work to go to DevOps work, maybe SysOps and all the other roles, and everything maybe became a little bit more complicated. Let's put it this way. If we go yeah, go ahead.
In that one, sorry. So if I'm understanding right, you have your load balancer that the client calls to get to the UI service, and then the UI service can call this other load balancer to get to its two services in this one. So it's a pretty simple explanation or diagram. In reality, though, behind your UI load balancer, there's a chance you'll have 50 services, right? When we build, I don't know, we have a little startup called Amazon.com that we run here, and it has, I mean, there's just APIs upon APIs. So managing this at the load balancer, and I think all of you alluded to this earlier or flat out said it, can be very complicated, right? Because you're managing this, okay, with two endpoints, no big deal. So maybe you have two paths here. Elastic, one's catalog, the other's carts. That's good. This works. But let's say you have 50 of them. You have to split across multiple load balancers. Your client has to be aware of that. So this becomes very complex in putting that together.
Yep. Absolutely, okay. Absolutely. Thank you for underlining that. Yeah, absolutely. That became a little bit more complex, and then you want to get out of this complexity. You want to just care about your application. And if you start considering that's the same application leveraging Service Connect, essentially, you remove the load balancer, you remove the Route 53, and you just rely on service-to-service communication, task-to-task communication in this case. UI service can easily communicate with catalog service and cart service, even if they're in different cluster, and leveraging Cloud Map for service discovery, essentially. So that's what we're going to see. And as Ollie mentioned, we're going to leverage sidecar proxy. And if we zoom into this architecture a little bit, let me give a little bit more details. What we will see in the demo.
I said sidecar, just to be very clear. I'm not trying to take credit there, but I said sidecar. As you were, I apologize.
Okay, and so set a little bit the scene. We're going to deploy these three services, UI, catalog, and cards. Each of them will have an application container and a proxy running next to the application that will take care of the service-to-service communication, and it will create a retry mechanism, will make a reliable communication, and whole nice feature of Service Connect out of the box. With this, I move on to the console and show you a little bit around and what's the setup of our system. So this is our two cluster. As you can see on the diagram, I show you that we are two cluster. In the first cluster, we have our catalog service. Essentially, this is two replica running tasks, the two replica tasks that are running the same container. And if I get inside the catalog, I can show you the two running tasks. And if I select one of those, you can see here my app is running as a container, and then next to my app we have ECS Service Connect. This is a proxy, sidecar proxy we have been talking about, and it's here supporting our hub.
I think it's worth reminding that like the feature of ECS is putting that proxy in your container. Yeah. That's right, in your task. Like the developers, the people writing their infrastructure as code is not having to say like, I want to put a Service Connect proxy in here.
Right.
That is something we're doing on like the developer's behalf. We're injecting it in there, so you don't have to.
Yeah, absolutely. And I'll show you in a bit how to do that as well. And we're going to do it live. On the other hand, on the other cluster, we have our card service, still the same running Service Connect. It's a sidecar proxy. And both services can communicate because are part of the same mesh. The mesh, in this case, is defined by the namespace associated to our cloud map. The namespace of our mesh is going to be ECS sample.local. And you can see here, there are two services are here. And then they can communicate with each other because they're part of the same mesh.
Hey, Simone, I'm going to interrupt you real quick. We do have a question, and I think Ollie alluded to it, but I want to be very clear. So the question is proxy added by default in ECS? So I don't know if Ollie or Simone, you want to grab that,
yeah,
but yeah.
No, absolutely. The proxy is not added by default. It's a configuration that you can add if you need that. If you need this feature of Service Connect, if you need service-to-service communication, and if you need your service mesh, essentially. So we're going to see how you can add this in your configuration.
But once you do the configuration, I know you're going to demo this, but then the service adds the sidecar. So you say, so basically you're flipping it on. Hey, turn this on. Here's the settings I want, and then the service puts the sidecar in there, but it's not by default. Correct?
Yeah, exactly. When we are building the service, we can say, I want the sidecar. That's it. Okay.
Cool.
And they're part of the same namespace, and they can communicate. Yeah. Okay. So now, I don't know if you notice, we are missing one microservice and missing a UI service. So our beautiful front end is not up yet. So it's for getting this error. So now let's.
This is usually where I would panic. I'm glad you're not panicking. So this is on purpose. God, no.
That's on purpose.
Okay,
that's on purpose.
Yeah.
We show you that the service is not there, and we are going to deploy it right away. So I'm going to copy this command, and given that it takes a little bit of a few seconds to deploy, let me run it, and then we comment it out. Okay. So here is the command that I was mentioning before. So we are creating the service. So maybe some of you are familiar with CLI of ECS, recognize this command. We simply create a new service on our cluster with the name UI, and with the task definition ECS sample UI. And we'll see a little bit much detail on the task definition a bit. The rest is just standard information about load balancing and network configuration. And all that you need to enable Service Connect is this bit. Okay, so just want to show you how easy it is to set it up, and you don't need to specify any complex configuration, let's say.
It's probably worth clarifying that we in this service you have like a load balancer and Service Connect because it is the UI. Yeah. Because it's the UI, you have a load balancer that you can access it outside of the mesh. But if this was like a back-end service, like the catalog or carts, you wouldn't specify a load balancer. You'd just use Service Connect and the proxies to communicate.
Yes, exactly, because we are deploying the UI that is in front end. Absolutely.
And I have a question here real quick. So I'm a big IAC guy. I love SAM. I love CDK. You're using the AWS CLI. Is that normally where you go, or can you also do this at an IAC level?
We can do it CDK.
Laughing at me. Keep it up, Ollie.
We can do it CloudFormation CDK, but just for demo purpose, I decided to run this command in CLI because I think it's easier to follow up and to understand what's going on. Yeah.
Okay, super fair. That's cool.
Okay, so essentially we define that this UI service is going to be part of this namespace, that same namespace that we saw before. We're going to associate this port name app 8080 that we'll see is part of our task definition with alias DNS UI. And essentially, on port 80, essentially, we'll be able to, within the mesh, we'll be able to refer to this service using HTTP/UI. Okay, so simple name for communicating with the service.
Can I run multiple meshes at the same time?
You can have multiple mesh in different namespace,
Okay.
but the service cannot be part of multiple mesh. So one service can be part of one mesh.
Okay, so all right, interesting. So I may be creating. How you doing there? They pay me to speak here. I may be creating a mesh just for catalog. Maybe my catalog's real, huge. So, and then I may have an entry point to my catalog that I may add to this mesh. But I could literally, my catalog could talk on one mesh, and then I could have multiple runs. I'm not sure you would need that, but it is possible. Yeah.
Yeah, I mean, the mesh represents the logical boundary for the service to be able to talk to each other, but yeah, they cannot be part of multiple mesh. Let's put it.
Gotcha. Okay.
So
that's
let's just to show you a little bit. This is the task definition. The task definition is a standard task definition. There is nothing related to Service Connect. There is no configuration of Service Connect, and the port name. Essentially, we'll be mapping on Service Connect this port name, app 8080. That is essentially exposing our application on port 8080 in container port, and that's it. And the rest is standard. No configuration of Service Connect. Something I want to make you notice here is that our UI service will have two environment variables for configuring the endpoint to the cards and the catalog service. And essentially, they will communicate with this short, nice, and simple name, HTTP cards, HTTP catalogs. This is the power of Service Connect service discovery. And if now probably it will be deployed. So let's, okay. It's worked. So we have a UI. And this is our simple retail store application. It's a demo application, so you can find it online. There is GitHub repo for this. And essentially, we have our catalog of futuristic item and our cards where we have our purchase for item. Okay, so nothing too complicated. But now that we kind of cover a little bit the basic, I want you to deep dive a little bit more on Service Connect and how this is configured. So let's, I'm using, that's just to explain, I'm using this IDE on EC2 Eastern running on the same VPC of our cluster, because I want to run a couple of tests that will require me to interact with the private IP of our container. That's why you will see me running the demo here. And right now I'm in this EC2 instance. I'm out of the mesh. Let's put it away. When I'm this IDE, I'm out of the mesh in the EC2 instance. But I want to show you how the mesh is working, how the communication on the mesh is working. And so now I'm going to run this command to get into the running container, our UI service container that is running, and I'm going to open a shell to have this container running. So the shell is here. So we are inside the running container, okay? So now let me install a couple of dependency just for clarity on the output. And here I can show you how easy it is to communicate with our catalog service. Essentially, this is just a curl command and calling the tags endpoint. And if I run this, okay, that's the output we get in from the catalog. And then we'll see some of the header from the Envoy proxy. That is, show you that the communication passed through the Envoy proxies. And as well, yeah, that's how it works. Pretty simple. And with this short version of the name, you can really communicate with that.
All right. So my question for you, I want to make sure I understood what you were doing there. So you're running on an ECS bastion, basically. Is that correct? And then you connect. Okay, so not a local terminal. You're on an ECS bastion that's in the VPC.
No, I mean EC2 bastion that is in a VPC, and then after I connect in a container, ECS container in the service mesh of ECS.
Right.
So
That's what I was trying for. I don't think I said it very well. You're on for EC2. I always say ECS when I mean EC2. You're on an EC2 bastion inside the VPC. Yeah, I don't even, there is no EC2 in my world anymore, right? And then you're connecting to one of the ECS containers in the mesh. Okay, I follow. So here's a question for you. Could I do this in a VPC enabled Cloud Shell? Yeah, that's
Yes.
right. That's cool.
Yes, you don't even have to be in the VPC to use ECS. Simone used ECS exec, which is like a debugging or troubleshooting feature of ECS. It's very similar to like Docker exec, which you may have used on your laptop.
Yeah.
So like to get you into the container.
How about though?
And it's powered by SSM. So like anything. Like as long as you have credentials to use SSM, you can exec in. So you don't even have to be on a Bastion. You can do this from your laptop. As long as you have SSM like the client installed on your laptop, you can jump all the way into the ECS container for debugging.
Okay. Yeah, exactly. And I mean, this is not the reason why using EC2 in this case is going to see afterward. When we are going to deal with private IP, that's why we'll need to be in the same VPC for simplicity. But yeah, this thing can be done even from Cloud Shell, absolutely. And to make it more clear for people, I mean, essentially for everybody who's listening, we are running here at this page. We are inside the app of the UI service that we just deployed. Okay. So maybe that's help.
Yeah, that's helpful.
And something else I want to show you, and how our application know how to connect with catalog is because when we deploy, when ECS deploy the task, is injecting this configuration in the host file, essentially redirect all the communication to the host catalog cards and UI to localhost. That's going to be then intercepted by the proxy, the Service Connect proxy, and redirect to the actual endpoint of the mesh.
So your domain is catalog for all intents and purposes in this, and then your endpoint was catalog also.
Yeah, I mean, this unfortunately.
No, that's all right. No, I get it. Yeah, but I'm just making sure of that. So HTTP:// catalog is that short domain. And then / catalog is the path name, / tags is still part of the path name. So, okay, I follow.
Yeah, fair enough. And as we mentioned, it can be supported across multiple clusters. This is the example with cards. So we have cards, and then this is just the health check of the card service. If I run this, you can see is still, I mean, okay, I get this a simple output, but to show you that it's actually connect, and we are across cluster, but within the same mesh. Okay, that's just to show you this. And I hope it's clear. So let's move on. With this, I want to show you essentially how easy it is to handle the communication. But I also say before we start that Service Connect, it can help us have a more reliable communication. So now I want to show you how we can make a more reliable communication with Service Connect.
And when you say more reliable, what are you comparing that to?
To not have Service Connect, essentially, but because you can, more reliable.
Sorry, I put you on the spot there a little bit, but I'm curious of what that statement means. So
yeah, let's put it this way: with Service Connect, you get out of the box retry mechanism, and you get a passive health check that essentially it verify if your endpoint are healthy, and if they are not healthy, they're being taken out temporarily of the mesh. And you can the Service Connect will simply not direct the traffic there for a period of time. So you would.
So that's a lot of stuff that if you went another route, you would either need to configure it or write it into your client.
Exactly. You need to handle everything by yourself. Instead, here you just deploy your application. Don't worry much about the connectivity, and then you deploy. Service Connect will support you and will improve your reliability. Let's put it this way.
This is the event bridge of containers. What's up? That's a horrible analogy. Just that, Ollie's freaking out right now. It's not. Let's not even go down that road. All I was saying is you get your retry and your error handling built in. Ollie's not going to sleep tonight because I just said that. So just relax. Stressing all out. I'm waiting for Sai to come on and take me off. So, all right, Simone, please go ahead.
Yeah. Okay. So now I'm going to retrieve with this long command. I'm going to retrieve essentially one of the IP of the running task of catalog. And so we run this, we're getting a little IP here. And now we're trying to configure. So this catalog essentially is the same as we did before. We get the same output. Okay. But this application is a little bit special. We instrument the application to generate error just for daemon purpose. And if we are configuring with this endpoint, with this API, we're configuring for this specific task to always return this error 503. Okay. So now we set this code and we can test it. If it's working, it's actually okay. And getting error, we get 503 error now here. Okay. So it is actually working. It's actually not working anymore. And now we are not getting a response because we are out of the mesh. So we want to test the capability of Service Connect by entering into the mesh. So again, I'm going to enter into our running container, same as before, of the UI service in the application. So we are back where we are before. And here, I can still communicate with catalog. And if I hit enter, you see this still keep working, even if I hit multiple times. This is because Service Connect under the hood is simply retry if one endpoint is failing, and after a bit, it will also remove my failing endpoint from the list of endpoints that can be accept traffic for my mesh. So it will give you a more reliable communication and a more reliable connection between microservices. Okay, I hope this makes sense. Let me get out of here. Okay, we can we fixed it, the application. Okay, and now it's back to normal. Nice. I don't know if everything clear. Any questions?
Yeah, so I'm going to repeat it in what I call Eric's dumb language here, but basically I'm going to simplify it. So basically what you did is you turned on some chaos. You turned on some breakage, right? And so, and what Service Mesh was able to do is detect that and either retry or route around it. Take it out of the mix, and the turning it off puts it back in the mix, obviously. So it's going to be, and I think that's an important thing to say, and tell me if I'm wrong. It's going to be all right. Hey, this task, this task is down, or this service, so that's a question for you. Was that a bad task or a bad service that you were?
It's about task. The task is being taken off because the task is representing endpoint of the mesh. Yes.
Gotcha. All right. So the task went down. So it said, I'm going to take that out of the mix. You hit these tasks, and it kept working. But it's going to continue to check that one, and it comes back up, and it puts it back in the mix. Am I correct on that?
It's more like after a bit, it's taking out for a period of time, and then it bring it back to the mesh, expecting that the task is back to normal. The L check mechanism is defined a little bit like a passive L check, in the sense that there is no an active L check, someone that is pinging your service, but it's more like it's sending traffic. It's understanding that the traffic the endpoint doesn't work because it's keep getting a lot of error.
That's where the retry comes in. Got it. Okay. All right, that makes sense. Does it work with will it work with Fargate to tell Fargate, hey, start a new task? And maybe I'm saying that wrong. Ollie, you can correct me. But will it ever actually kick a task out and have it create a new one?
I don't know. I think this could be for a moment used to kick out a new task, but I don't know. Maybe Ollie, you want to comment on this?
Yeah. So the answer is so ECS has its own health check mechanism to decide if a task is healthy or unhealthy, and so when you define a container in the task definition, you specify the health check, and Simone had a health check for the UI container he showed before. If that health check fails, ECS will replace it.
Got it. So ECS, but not Service Mesh or Service Connect. Got it.
Correct. So I don't know when Simone turned on that feature flag, like if it starts failing the health checks of the container or not. And if the answer is no, then ECS won't know that it's a badly behaving application. And if that's the case, I would argue it's a poorly written health check. The health check should know that return on the feature flag. But if we haven't.
Yeah, that's something I was going to call out. Okay, so when I'm configuring this, I need to make sure I'm thinking through, does my health check kind of match so that I know ECS is going to also realize it and restart a task if there's a problem versus just, oh, that's bad, let's bring it back in. Oh, it's out, let's bring it back in. So what's up? I just brought that to yeah, there you go. That's sidecarring if I ever heard it. So, all right, back to you.
Okay, so and we explore different capability. Now I want to show you something about how we can improve security leveraging Service Connect. Essentially, we're going to deploy another part of our application and will expose our application using HTTPS, and we also create an interconnection between all microservices using TLS. And let me give you a little bit, for the next slide, a little bit of overview of what we're going to deploy. Essentially, we're going to move to HTTPS from a load balancer, and we're going to connect this load balancer to a TLS endpoint provided by Service Connect from a UI service. And then the proxy will communicate with catalog service and card service using TLS, completely using TLS. So we're going to have completely encryption, service-to-service encryption enabled. Without,
and this is critical in a lot of industries, right? Absolutely. We see this in finance and heavily regulated industries. They got to have this encryption even in transit, even though you're behind the load balancer.
Yeah, exactly. This is very important for many of those industry, and it's a lot of headaches and a lot of work to set it up and work with certificate, and you can get it done quite easily with Service Connect, essentially. And we're going to show you how to do that. So let's clear again here. So I'm bringing up again another command. It's quite long. I run it and then I'll bring it back up again. So this, we're going to create another service here. It's called, this time it's called UI TLS. And again, we're going to attach the load balancer as before. These are different target group because it's TLS target group, and we're going to see maybe a little bit of more details. And here again, the Service Connect configuration. Similar what was before, but this time we have this extra bit where we actually configure the TLS, the certificate. Essentially, this few line of code can enable your TLS encryption, service-to-service encryption. So pretty easy to set it up, let's say. Essentially, this is a private certificate authority. What you need is a private certificate authority from AWS, one of the AWS service, and our role to provide to Service Connect the ability to connect to this private certificate authority and to generate specific certificate for your running task. Essentially, then with this specific certificate generated from the certificate authority, you will have an encryption, service-to-service encryption set up.
Okay.
Okay.
All right.
And
it's probably worth pulling out, like, this is like you're putting like the TLS certificate here for the UI service. You would have to like put the same TLS definition on the carts and the catalog service as well, right? You have to kind of turn on TLS as service by the service.
Yes, you need to turn on service by service. It's actually, the other one are already TLS enabled. So let's have a look. If I get to my namespace, now we see we are getting cars, catalog, and UI TLS. Nice. Each of them is TLS enabled. I did that before joining, and essentially now hitting UI TLS, all the communication will be service encrypted.
And then you would take down the other one.
We can take down the other one.
Yeah.
So this is again to show you that the application is back running. And you see is on HTTPS. In this case, it's red because it's just a self-signed certificate.
Okay, all right.
And
I was going to call you on that.
No.
Yeah, that's fair. Okay.
Just for demo purpose, of course. But okay, so just want to show you that was HTTPS. So it was external encryption and nothing to do. It's just load balancer. It has nothing to do with Service Connect. But I want to show you how the load balancer is behaving under the hood. So this is our load balancer. And here we have our two listener. One is on 443 HTTPS, and this is our target group. So if I get into the target group, I can see we're having our healthy task that still running on port 8080. But
I got to call you on that. Hang on a minute here. Hang on a minute. So, I'm not an expert in this, but you were running a non-encrypted on an 8080. So port doesn't matter then, right? You're still running TLS because obviously I'm thinking load balancer. I'm thinking it has to be 443, but that's not the case here. I can apply the TLS to the 8080. This could be 8081 or 8085 if I wanted to, as long as I've applied the TLS settings.
Yes, exactly.
Okay.
And that's why you see here HTTPS essentially. So, and we're going to try it by hitting the endpoint directly from our EC2 instance. And this essentially is our TLS encrypted endpoint for using Service Connect. So going back here, let me clear again the screen. And now I'm going to retrieve the IP address of our UI service with TLS enabled, the one we just deployed. And I'm going to show you how we can simply call out this endpoint, HTTPS of this IP, port 8080, and we're going to get back the response. Don't to highlight this handshake mechanism. So it's actually the handshake is working on TLS, and then the envoy header, and then the response. Okay, this was just the health check of the application. So response is pretty simple. But yeah,
tell me about the cert. Is this a self-signed cert here as well?
This is certification derived by the Private Certificate Authority. So it depends how you build your Private Certificate Authority, which secure with the material. I'm not really an expert on security, so it depends how you build the security Private Certificate Authority. It can be a certificate, a valid or not valid certificate.
Okay. And do we have a service that kind of handles this for you?
Yeah, we have a AWS Private Certificate. Will handle for you. It will give you a Private Certificate Authority, and you can bring your own material and build your own Private Certificate connected to your chain of trust.
Service Connect is acting on your behalf of like creating a certificate from the Certificate Authority service, and then retrieving the material, putting the material in front of Envoy, and then like rotating it when it's going to expire and stuff like that. So like,
oh my gosh, that's beautiful. Okay.
Yeah, you create a private certificate authority in the managed service, so you now have your CA, and then then Service Connect is doing the go get me a certificate, retrieves it, and then encrypts its endpoint.
Okay, that's huge. When you go back, I mean, I don't. You're both, young pups. I don't know. We'll see. But I remember having to go get certificates, and I mean, it would take me all day to read the document and get it right, and then I'd have to do it again the next day, and I couldn't remember because I guess that one's on me for not documenting it. But yeah, for that to be kind of offloaded and for the service to be running that for you, that's huge. That's absolutely huge.
Right. Especially if you think about the usual standards, you use short-living certificate. So certificate that need to expire quite often. So you need to do this process continuously. So you need to have a mechanism in place to have a high standard of security in this case.
Gotcha. And this should just be, would you say standard practice, with as easy as it is here, or maybe you just made it look easy, but it looked pretty straightforward to me. Does it make sense? When would you not run NTLS behind?
First off, caveat: this is TLS for encryption, not mutual TLS for authentication. Slightly different. We're like authentication. It's something we're working on, but right now we're just supporting TLS, which is like end-to-end encryption.
Gotcha. I just like to throw out random terms and let Ollie correct me. It works. It really works for a show. So
if he says event bridge again,
always what I call my sidecar. So. I did say event bridge. Come on, the analogy worked, kinda. It's not advanced. There's a lot of places that it fell on its face, but for the retry part, solid.
I do love event bridge, but odd analogy.
All right, fair enough. Okay, so clarify, this is not MTLS. We're not doing mutual TLS, which I know is both the client and the server authenticating each other. Boom. Let's just say Eric knew that. I looked it up while you were making fun of me. So this instead is TLS, meaning encryption between the two endpoints.
Correct.
Or the two services. Yeah. Okay, gotcha. So back to my question: when would you not use TLS? I mean, it used to be that we wouldn't because the decoding encoding used to take latency and bandwidth stuff like that. Is there a reason to not use it, or should this just be standard practice?
Right. In general, I can say that enable TLS anyway, it will cost you a little bit more in terms of resources for your tasks. Okay. So you need to be careful on that, especially if you have a lot of tasks. And if you need Service Connect because you need to be compliant and you need to be your communication need to be encrypted, okay, definitely go for it because the overhead is minimal. But I mean, it's still there is some overhead, and you need.
There is some overhead. Okay, good to know. Okay, all right, that's really interesting. So if I'm just building, like, if I'm creating a blog for my mom to read, which is, the only person, but my mom's a hacker, I'm not lying, so I have to be careful. All right, very cool. All right.
Okay. Last to show you it mostly for completeness, let's say if you want to review our certificate, you can use this OpenSSL command and it will give you the certificate that was applied to your Service Connect endpoint, and this is our kind of 509 certificate description. Okay, maybe just to make it a little bit complete and show you what's possible.
Before you clear it, Ollie, when you look at this, do you know what this means? I mean, can you look at this and decipher it all? This is all gobbledygook to me. I'm just checking to see if,
I was reading the bit at the top. So in answer on a short-lived certificate, this one runs for a week, and the overview is called ECS sample.
Even that's pretty good. Yeah. I look at this, I'm like, I don't even know what language that is. But okay, I see the validity. All right, that's good. Okay. Yeah,
that's some
all right.
Interesting information.
Yeah, that's fair. So, all right. Hey,
okay.
Simone, do you have something? I'm sorry. Do you have something else? Just a heads up, we're at about a 7-minute warning, so I want to make sure time-wise. But is there anything else you want to show?
I just want to show a last feature because we talk about security, we talk about reliability, and now let's go for monitoring and a little bit of metrics if you want. I'm going to be quick, but once you enable Service Connect, essentially, if I go back to our cluster and here, you get in ECS dashboard directly in our UI service, you get out of the box this dashboard that give you a lot of information on what's going on with your service, with your communication, active connection, and you see a little bit of number of connections because I have some script that generates some network, some synthetic traffic in the background, and how many requests were okay, how many requests were some error, and everything here handy, and also Beautiful. It can be. Of course, is going to be also in CloudWatch, so you can integrate them. Maybe creating alarm. That's on CloudWatch. Similar things. So you get the diagram. I just select a couple of those connectivity and metrics, and you can create, of course, alarm, diagnosis, and you can also enable your scaling mechanism based on traffic or whatever you need, or send notification and so on. Yeah,
this is huge. It's a story about your app. This is great. In a past life, I was a solutions architect, believe it or not. And you talk to customers like, do you log your data? Because if I'm not mistaken, Simone, you can create alerts off this, obviously.
Yeah,
right?
Of course.
Yeah. We have people that save logs, but they don't get the story like this. And so because this is already in here, and I'm sure you can customize this and add more. This is incredible. Really slick.
Yeah, a lot of metrics, and we can leverage to create dashboard and nice. And alarm and so on.
Nice. Service Connect for the win. This is great. All right. So if you want to know more about this, and hopefully you do. I mean, obviously there's a lot going on here that you can do. We've got a couple of things. Talk about the workshop real quick.
Yeah, many of the command and the description and the information that we saw in this demo, you can find it on ECS networking workshop. Here, a QR code, you can scan it, and the link behind that, below that. Or if you want to know more about ECS in general, all the features available, I invite you to run this this workshop. It's in ECS Immersion Day. It covers a lot of feature of ECS, a lot of basic feature, and but it show a lot of details. And yeah, so for me, I would say that my call to action for you is get in touch with your AWS representative and make it run this workshop for you, and let's try ECS in action.
Yeah, that's perfect. I was posting a link on these, and it's not showing, so I'm going to post them this way from the actual system. There we go. I think there's something wrong with, I don't know, my account or something. But so what I've done, yep, they're showing up. They're coming from the Containers on the Couch. I've posted both links. You can see here for the Amazon ECS networking workshop. You've got the QR codes in front of you as well. So please, yeah, check those out. These are a great way to kind of walk through them, learn how to do it. Simone, amazing demo. This is really good stuff. In all seriousness, I still call myself new to ECS, so I just learned a ton here on why I would use this and how to use it. And sometimes I look at it and go, I'm never going to figure this out. But the way you explained it, that was really good. Ollie, always, poor Ollie's been on my team and had to work with me, and so gracious to me and always teaching, and I really appreciate that. Thank you very much for all y'all are doing. And with that, any shameless plugs you want to throw out before we shut it down?
The only thing I was going to say is if you're going to the AWS London Summit, we'll be doing the networking workshop live. So I'll be there. We'll be running that same workshop live. So if you want to do some hands-on at the London Summit in the Excel in a few weeks, we'll be doing it there.
Nice. If you can get to London, do it. These are a lot of fun. They're a great way to learn, and they're always free. So, all right. With that, Simone, thank you very much. Ollie, thank you very much. I'm going to take us out. See y'all later. Thank you, Sai, for producing from the background there. All right, here we go.